My name is Jay Robnett. I live in Newbury Park, California. At the time of my learning experience, I'm going to relate, I was 20 years old. I was a junior in college. The topic that we were studying at that time was invertebrate zoology, and actually the evolution of the invertebrates. This happened at the University of California, Santa Cruz, in the invertebrate zoology classroom, which was a class that was taught by 2 instructors and was a small class. There's only about 40 students in it. Although this was a project, and it was not a group project, it was just a single project, the project was actually a culmination of many other things that we had done in the class, including field trips and going to the marine lab and doing our own research. So the project I'm going to relate to you was actually a paper that we wrote that included a diagram that we had to draw. And the actual assignment was to create our own creature that the instructor had given us certain criteria that we had to follow. But we had to put together our own little creature that was derived from another creature that we were studying. So the idea was to apply the principles of natural selection and adaptation to the design of the animal and how a present animal might evolve over time. What I learned the most from this was rather technical, and I'll try to keep it short here. But the idea was I took a very common animal that you find in California in the intertidal region called a chitin, and I made it into an air-breathing chitin. The chitins right now, they just live in the water, and they can't live on land themselves. Their cousins, the snails, of course, live in water, live out of water, they live everywhere. And so as I was doing my project and trying to make an air-breathing chitin, I was wondering exactly why these 2 related groups of animals were so different. What made it so easy for snails to adapt to all these different places while the chitin didn't? And I know that's exactly what our instructor wanted us to think about. And the basic lesson that I got out of it was that evolution is not a step-by-step process for every group of animals. There's a lot of randomness, there's a lot of just pure chance, there's a lot of trying to solve problems that your group of animals just were given. And evolution is really extremely complicated, as complicated as life itself. All these things kind of came together for me as I put together the paper and drew my little chitin and did that. And it's such a humble assignment because, no one knows what a chitin is, not even most of the people in California. But yet, the basic lesson of what evolutionary biology was very powerful. And I was amazed afterwards how well the assignment was designed, and as a summative assignment, how well it focused everything we had learned in order to come to this very basic truth that the instructor was trying to get us to learn. And he didn't have to tell us this. We just got it because we, in this assignment, had to use our own creative energies. And by exploring things and not just memorizing them out of the book, you were able to make those connections that he wanted us to make and come up with this kind of wonderful summary idea about his class. And I think that not only did this, make a very nice experience for me to, to have that kind of realization that I'd learned something really basic, but also just in appreciating how he designed the whole project, it really made me want to be an instructor myself and try to get other people to have that same kind of process and success in learning about these basic truths too. So there it is. Thank you.